Hello everyone, welcome to Brilliant Kuwait. Today we are going to discuss a question which is asked in 2025 JEE under the topic continuity and differentiability. So the question is, let x denotes the greatest integer function and let m and n respectively be the number of points where the function f of x is equal to greatest integer of x plus modulus of x minus 2 in the interval minus 2 less than x less than 3 is not continuous and non-differentiable. Then m plus n is 6, 8, 9 or 7. So here, if you look at the question, there is greatest integer function is there and modulus function is there. Because of the greatest integer function, I have divided this interval into 5. That is minus 2 to minus 1, minus 1 to 1, 1 to 0, 0 to 1, 1 to 2 and 2 to 3. And if you look at the modulus function x minus 2, for x less than 2, the value, we have to open the modulus function with a negative sign. That is this. And for x greater than 2, we have to open it with positive sign. So if this is clear, let's move to the next. So here, for these splitted intervals, we can see that the values of the greatest integer function are 2, minus 1, 0, 1 and 2. And as I discussed before, the modulus function will open with minus for the first 4 intervals and with plus for the last interval. So when we add these two, we get the function minus x for the interval minus 2 to minus 1, minus x for the interval minus 1 to 0, 2 minus x for the interval 0 to 1, 3 minus x for the interval 1 to 2, and plus x for the interval 2 to 3. So our functions and the intervals are clear. So next, move on. Now the functions and the intervals are set. Now we have to check the point where the function are continuous or discontinuous. The points are minus 1, 0, 1 and 2. So for the point minus 1, we have to find out the left hand limit and right hand limit. If you look, the left hand limit for the point minus 1 will be minus x and right hand function will be 1 minus x. So when you substitute minus 1, you will get 1 and 2. That means this limit does not exist. Similarly, for the point 1, the values we get 1 and 2, that means that also the limit does not exist. Similarly, again for the point 1, we get 1 and 2 for 1 and 2 points as well. So the limit does not exist. So here the 4 points, that is minus 1, 0, 1 and 2 are the points of discontinuity. So m will be 4. For all the discontinuous points, the function will be non-differentiable. So the value of n will be 4. So m plus n is equal to 4 plus 4, that is equal to 8. So 8 is our answer. So the option 2 is our right answer.